Hello, Math Elites. I want us to figure out how we can solve this exponential or tetration problem together. All right. Now, the first thing I want us to think of is what is tetration, because we are very familiar with exponentiation. If I have 3 tetrated to 2, it simply means in exponentiation form, it simply means 3 raised to the power 3. Right? So if I have maybe 3 tetrated to 5, it's going to be like 3 to the 3 to the 3 to the 3 to the 3. 1, 2, 3, 4, 5. So this is a power tower, right? So this is what tetration is all about. And now you can see that we can actually transform tetrations to exponentiation, right? Since we know the number of towers or the number of times you're going to take this tree in its powers, then it's easy for us to simplify it that way, right? Yeah, so let us have this in mind. Then if you look at this one, we have 3 tetrated to x tetrated to 2. We don't really know how we can simplify this because we don't know what the value of x is all about. If it was just maybe x to the tetrated to 2, this would be x to the x, right? So that is how you can transform this guy in its exponential, in its exponential form. So let us go over solving this problem. Let us see how we can transform 27 in its tetration form. You know, 27 is written as 3 to the power 3. And so because this is 3 to the power 3, which is what we have here, I can put it in tetration form as 3 tetrated to 2. So we have 3 tetrated to x tetrated to 2. Now you see they both have the same base. The whole idea here is either you're putting them in tetration form or you're putting them in exponentiation form. So now we've succeeded in putting these guys in their tetration form. So we can cancel out the base and equate the exponent. So we have now, this base cancels out. So we have x tetrated to 2 is equal to 2, right? Good. So now you know what x tetrated to 2 is all about, which you just figured out here. So this is just like x to the x is equal to 2. Now, how do we figure out the value of x in this form? All right, I'm going to take the natural logarithm of both sides. So I have the ln of this quantity is equal to the ln of this quantity. And remember from the laws of logarithm, this guy is going to fall behind. So you have x ln x is equal to ln 2. All right, I want us to think of the Lambert W function, the Lambert W function, or we call it the product function. So it says that if you have maybe the Lambert W function of x exponent x, the whole result is going to be x. Really simple. So when you have the Lambert W function of x exponent x, your result will be x. So in other words, if you have the Lambert W function of 2 exponent 2, the result is going to be 2. So that's pretty much how it works. And also, if you have a Lambert W function of ln x exponent ln x, what do you think the result will be? Of course, the result will not change. The result will still be ln x. All right, so let's have all of this in mind. And if you look at this left-hand side, it's almost looking like this form, right? You see the ln x is right here, and now we have x. So we need to see how we can transform this x in the exponential form of this. Remember, x can be written as exponent ln x because you know the exponents are antidote of each other, so they can always cancel out, so you get x. So you know that x can be written as exponent ln x. So I'll go further to write these guys as ln x, which is this guy right here. Then this x now is the same as exponent ln x, right? Then all of them is equal to ln 2, right? Okay, now you see, now if we take the Lambert W function of both sides, so we're going to have the Lambert W function of this function here and the lambda W function of this quantity here. Now, if you look at this guy, if you take the lambda W function of this guy, you have ln x. So that is what we're going to have here. So this result, we're going to have ln x in our left-hand side, which is equal to the lambda W function of ln 2. And so to get rid of this exponent here, this is actually log to the base e. This is actually ln x is actually log to the base e of x, right? So if I take the exponent of both sides, it's going to cancel out, right? So if I take the exponent of here and the exponent here, so now have x is equal to the exponent of the lambda W function of ln 2. So this is going to be what our answer for x is going to look like. So you can plug these guys in your calculator and see what the value of x will be. Thank you very much for watching. If you love what we do, please consider subscribing. And thank you very much for watching one more time. Have a wonderful day and God bless you. Bye-bye.